Hello and welcome back to Mikey's Flightdeck. In this video I will show you how I integrated monitors into my MIP and brought them to life. When you are starting to plan to build your own MIP, then you should start thinking about how you want to simulate these monitors here. You can try to buy monitors that fit exactly into these places here, but this will cost you a lot and it will also be a hard task to find such monitors. And even professional manufacturers will recommend you to use normal PC monitors and fake these displays here, or they are selling you such monitors with the MIP when you buy it from them. So my decision was to use two different kind of monitors, an 18.5 monitor for these displays, for the captain side and the first officer side, and a 15-inch monitor for this area here. Here is my 18.5-inch monitor, a widescreen and a TFT display, and you can see this will cover the width of these two monitors here already. In the real Boeing they are a little bit bigger here, and I think I will build them after the original measurements, and this monitor will fit here in the width. But when it comes to the height, you can already see the monitor is higher than these displays here. So it can't go too much above these displays because here are already the next items to come. So it has to go deeper here, more underneath these displays. And so it will stick out here a little bit. And I will have to think if I will let it stick out here, but this can be a disadvantage of the light that comes from the monitor. I think I will cover it all, making the MIP a little bit higher here and going more down here and covering the whole monitor. And as I said, when it comes to the middle part here, I have this 15-inch monitor. There is really not much space. I will have to look how I will arrange this all and how I will build the gear lever here so that it all fits in there. And like on the first side here, it will stick out underneath this display a little bit more, so it will be covered inside of the MIP. I removed as many plastic parts as I could to make the monitor as flat as possible. The 15-inch monitor didn't need hot glue, but other tools. This is how the three monitors are aligned behind the MIP. And the advantage by aligning the single monitors behind these screens here is that the bottom sits flush to the bottom bar here of the MIP, and then they slide here behind the panel. There are some things I have to do before the installing here. The most important thing, I have to think about the method of fixing the monitor behind here. I think I will come out with something like a wooden bar here that sits behind the MIP. And to prevent the monitors from sliding from the left to the right and so on, there are some screw holders here behind the monitors in the metal frame, and I think I can use one of these holes so that the monitor will stay in its place when it is fixed. When I now have the MIP out of my cockpit, I will use the chance to glue all these nuts here in place behind it, because it is always very difficult to screw in the screws that holds the single panel components, because you can't grab behind it and hold the screw from the back, so you need a second person. And yeah, to be able to make this alone, I will glue them in place with epoxy, and I hope they won't move then when I install a screw from the front side. And of course, it couldn't be that simple. Yeah, the epoxy glue doesn't hold the nuts behind the MIP. The surface of the acrylic is too flat and the glue doesn't stick to it. I have made this experience with hot glue, but I didn't expect this with epoxy glue. Yeah, but I think the turning force turns it away from the material, so this doesn't work. And the second thing, both outside monitors fit well, but the middle one collides with two nuts here on the right side of the gear handle. If I would have looked carefully to my designs, then I could have seen this before. I didn't. Okay, I have ordered now these melting nuts, which you use for melting the nuts into your 3D prints. And I came out with the idea that maybe these also can be melted into holes in acrylic. This is so my last hope to indent this nut here. I have prepared an experimental piece of acrylic and will test it there, and if this test comes out good, then this is here my rescue. I have prepared this test piece here, which shows exactly the situation I have at my MIP. An outstanding part here, which I'm afraid that it would bend maybe when I bring too much heat in there, and a 4.5mm hole in it. These melting nuts need a 5.5mm hole, and so at this piece I have countersunk the hole a little bit with this bit here to have a good starting point for the 5.5mm metal drill. And so I came out with a 5.5mm hole in here. And now I can insert the nut. I have prepared my soldering iron and set the temperature to 200 degrees. Now let's see if the temperature is high enough. I didn't want to start with too much heat for the beginning. So insert it and heat up the nut. Oh, it's going in. It's going in. Oh wow. A little bit deeper. Cool. This came out absolutely fantastic. I don't know if it's sharp enough on the cam to see. Absolutely flat here at the surface. And if this works, then this can be a method for the whole MIP, I think. Wow, I'm still completely flashed that this came out so good on the first try. I will now remove the gear handle, insert the two melting nuts, and if this comes out good, then I will replace all the nuts behind the MIP with these melting nuts so that I won't need any assistance from the backside of the MIP when I want to move out any components here. Maybe you have seen the worst thing that could happen happened. When I drilled in into this piece here, the drill was pulled into the material, and this was too much force for the material and it exploded. That didn't happen at the test piece, of course. Here, but what I found out is that when you drill while the drill is rotating backwards, then this doesn't happen and you don't need to drill through the whole material. I finally said I'm making a start for the melting nut and then let it find its way into the material. So let's see if the remaining 5 nuts give enough strength for the gear lever. Oh, okay, yeah, there is enough strength in the whole construction here to hold the lure or the layers of this lure panel here in place. I can really feel the force when I'm bringing in the screws that is pulling the panel to the back side of the MIP here. So this is really a big improvement to this whole MIP here. I definitely will go on, but I will be careful with the drilling. I will apply this foam strip here around the edge of the monitor so that no dust can come in here and be caught between the monitor and the acrylic glass. The button PCBs are held in place with some 3D printed standoffs. Now all monitors are in place, all the switches are in place, everything is finished here concerning the construction. It was a long process and I don't know exactly what was said before from me to you, and so please forgive me if I repeat something now. Just for you, a quick overview how these monitors are held in place. The 2 outside monitors are held in place by 2 wooden beams. The middle one only by 1 that goes here diagonal, because there wasn't much space to screw in here, because there were other screws in the way and also panels in the way, so I just reduced it to 1. One of the bars always has a screw through it that goes into the monitor, so this prevents the monitor from sliding to the sides, and the other one brings pressure to the monitor on the other side, so that the monitors are pressed from 2 points to the MIP, and this is holding really well here. The buttons you have seen, I have glued them to the back of the monitors, so when I have to disassemble it and to bring out a monitor, the buttons will come out as well. So this is a really unusual test situation here. The only place where I can test this MIP panel here is underneath my desk, because it's too big to be on top of the desk and it has to be near to my computer, and I don't want to bring my whole computer setup down to the basement just for this testing purpose. And then I still would have the challenge of routing the cables to the monitor. So they have to be near to the computer. Yeah, so I can't show you everything like I've done in the past, but you will see the result and if everything is working. What will not be part of the configuration video here are the dimmers in the knee panels. I've had this in the knee panel video. I haven't installed yet all the lights that are controlled by these dimmers here, and I will have to come out with some kind of 12-volt distribution later so that every dimmer can control the light segment what it is built for. Also, the LED and the switches here will not be part of the video. I think if you have followed my video until this point, you know how to configure these. I will show you the place in the Prosim configuration where you can find all these values here, but I think then you can go your own way. But what will be interesting in this configuration will be these potentiometers here that control the brightness of the two monitors here, or at least the graphic that is shown here on this single monitor. But first of all, I have connected the power supply to the monitor, and now we can check if it is still alive. So power is there, and now let's push the power button on the back here. Yeah, and the monitor is coming to life. I hope you have seen this. There was a short sign of life and a light on the back is also lighting up. So this is still alive, and the next thing is to get the image from your computer to the monitor here. I thought this couldn't be that difficult, but there were some problems. My graphic card has a DVI port. I thought it would be possible to use a DVI to a VGA converter or plug adapter to connect the monitor so that I could run 3 monitors with my graphic card, but there wasn't an image there. I then tried to disconnect one of my monitors, which is connected with an HDMI cable, and I used an HDMI to VGA adapter, but the same result. The monitor wasn't recognized, no image showed up. And then I tried the HDMI to VGA, I would call it a converter. So there must be a little bit more electrical stuff in it. Yeah, and this finally worked. I don't really know how I will run all the 3 or later the 4 monitors with a dedicated computer. I will come out with some solution in the future, but now for the testing, this is enough here. Now let's dive into the configuration of the monitors and the potentiometers. Everything starts here in the installation folder of your Prosim software, and there you have this Prosim display folder. For every monitor that you want to be controlled, you should duplicate this folder and make a dedicated folder for it. For example, I have duplicated it here and renamed it to First Officer's Output. This instance will control everything concerning the 2 monitors of the First Officer. When you start the software, you can enter the setup mode by pressing F12 on your keyboard, or you can also find it in the right-click context menu and then open the displays for the First Officer here, or just pressing F3 and F4. And maybe this can happen to you that the monitors don't show anything. Especially when you leave the setup mode, you can see you will see nothing. And there can be a tricky reason for this.
It took me a lot of time to find this out, and one of the reasons can be the configuration of your airplane. When your airplane is in a condition that there is not much energy, or the airplane is in some way not ready fired up, then these monitors are black, also in real life, and this is what is simulated here. Another thing that can result in that situation here can be the configuration file in your Prosim system folder here. Everything that you insert here will be stored in a config XML file. I have done this too, and all my configurations are in there. But all these configurations are made in mind that there is an overhead and a pedestal that helps the plane to be configured. Now, at this point where I just want to test the monitor of the MIP, I don't have my overhead here connected to the PC. But then Prosim doesn't know how the switches should be. And so there can be a state and a configuration of your airplane that this monitor will stay black. So I came out with a solution that I have renamed my config and stored it under another name temporarily, and then started the software again. It will create a new config XML file, which will be completely empty, and you can start from ground on. For me, at the end, a good solution can be that you just display a static image here. And these you can find under Displays Static, and take the First Officer's PFD and ND. 1 and 2. And these two images or videos will always be available, and you can use them as a reference when you want to test your monitor now. As long as you are in the setup mode, these images can be clicked here. You will see the green border around the image, and with your mouse you can just drag and drop it at a point where you want it, just roughly at this moment here. And when you have done your first configuration here, then you can take the whole window and move it over to your other screen. And then by having an eye on this screen, you can fine-tune it. You can use the mouse, or for finer configuration, the arrow keys, and move it up, down, left and right. And with turning the mouse wheel, you can zoom in or out. And I think a good way to place it on the monitor is to look at the top left corner here, arrange it so that it is in position, then zoom in or out so that the bottom line also fits into your monitor, and then you can scale the width. And for all of you with a German keyboard here, it will be very difficult to find the right keys for scaling the width, but here comes my hint. It are these keys here. When you have done all your configuration, then you press F12 to leave the setup mode, and then you're ready to go. In Prosim, I have declared the new devices up here in the MoboFlight modules tab. My Arduino N is the only Arduino that is connected at the moment, and down here you can find the devices N44 and N45, which are the two potentiometers, and the only thing that must be declared is the middle pin that is connected to the Arduino. I have already made an input configuration here, N44. It knows to which device it should listen, and it communicates the value on this offset and the following offset because it has a size of 2 bytes. The value goes directly through, and let's have a look to what values we get now. For this, you can enable the logging mode here under settings and enable the logging. And now let's have a look to the values, how they change when I turn the potentiometer. So you have seen this. The values change here from 1312 as a lowest value up to I think 1022, no, 1020 and so on. I have read for a good potentiometer you can receive values from 0 up to 1023. In Prosim, you can enter the configuration here under Config, Configurations, and then here in the Combined Config tab under MIP, and down here in the Analog category, you can find the right inboard and right outboard brightness for the first officer. I have declared two 16-bit unsigned offsets, starting from this and this offset here. So, and when I start this MoboFlight connection and turn the potentiometer, you can see something is already happening. Prosim can work with these values and the brightness of the displays goes up and down. There's only one thing you can see, but I will tell you that isn't working here, because when I turn the potentiometer clockwise, then the brightness is going down. When I turn it anti-clockwise, the brightness is going up. This is a problem because I have switched the two outer pins of the potentiometer, the 5-volt connection and the ground connection. But instead of resoldering it, I can just fix it here in the software. And for this, I go here to the set value and I modify it just by taking my maximum value, 1022, and subtracting my value from it. And so I turn around the output value. Yeah, and when I'm now turning it clockwise, the display becomes brighter. Yeah, and this is already everything you have to know for the configuration. Just a little bit about the offsets and how to handle them.
Here, a small but very important step in your cockpit project that brings your MIP panel finally to life. Some thoughts for the future have to be done, especially how I will fire up these monitors later, maybe with a dedicated computer, a graphic port splitter, something like that. I don't know, I will have to find this out later. For now, the proof of concept has been done, this thing is working, and all the rest will be shown in the future. And if you want to build your own MIP panel at home, you can find all the needed files to cut out and engrave your own panels, as well as the 3D printing components here on the download page in the member section of my website. So now I have to move on to the next step in my cockpit project, and if you don't want to miss this upcoming episode, then subscribe to my channel to stay informed about any upcoming new video from me. And I hope we'll see us soon back on the flight deck. Like this and slide them behind the panels. Alter, jetzt ist schon wieder Supernova. Ne, es geht nicht mit dem Licht. Jetzt kommt wieder Sonne. Jetzt ist Supernova im Bild. Das ist scheiße.